we can divide the evolution of Internet in Internet of Documents, Internet of Applications, Internet of People, and the next step will be the Internet of Things. IoT is a system of interconnected devices and machines that can communicate and exchange and share data that will be used in several applications. However, as good as it sounds, IoT presents several challenges. If we have a large number of interconnected devices right now that are vulnerable or already infected, imagine if we add smart cars, fridges, smart healthcare machines. Imagine if every device that we use in a normal basis is infected. That could be really bad, not only for our privacy, but also for the electrical consumption that will increase. One of the worst scenarios will be an infected healthcare device. That could be catastrophic. Developers should be aware of the vulnerabilities of all the IoT devices. Another challenge is regulation. If there are laws requiring security, nobody will provide security to the device and to the data. All the devices need to have certain rules, laws, and security regulations, such as an ISO rule. These laws should ensure the safety of the user, including regulations that specify what the company should do with the data of the IoT users.
Let's continue with the compatibility challenge. Let's say that you have a fridge from company A and you want to buy an air conditioning from company B. You expect them to communicate in a proper way to fulfill some tasks. But the IoT devices are not compatible because each of them uses different protocols and technologies. How can we solve this? Interoperability between all the IoT devices is needed. Thus, IoT devices must implement basic standards and technologies to make communication possible. However, this is not a technological issue. Companies must approve these standards, which could not be convenient for them under an economical point of view. Last but not least, the connectivity challenge. IoT architectures must be global in real time and scalable. Due to the exponential increase in the amount of IoT devices, regular approaches such as the client-server model won't scale successfully. In addition, the servers must accomplish computationally expensive tasks, and the devices will periodically send measured data to the servers. With all this said, the network will increase its latency and break the real-time communication. Thus, new approaches are needed. Some of the most known approaches are the peer-to-peer communication and the distributed architectures. For instance, the DIAT and the distributed stream processing.